With polygons, what we're going to do, be able to find and use interior angles of polygons and exterior angles. A couple of things, got to remember: convex, concave, convex polygon, these are the ones that we're going to be using most of the time. Concave, we're not going to use very often. Remember, concave, that's a polygon where one of the angles is more than 180 degrees. We're not, all the formulas and stuff don't work with concave polygons, so we're not going to be doing them so much. Convex polygon is just what you normally think of as a polygon. All the angles are less than, all the interior angles are less than 180 degrees. Diagonal of a polygon, diagonal connects two non-consecutive vertices. Remember, a vertice, just a corner of the polygon. Non-consecutive means they can't be right next to each other. They can't be neighbors. They can't go in order. They got to be non-consecutive, because if they're consecutive, then they're already connected by a side of the polygon. They're already connected by a segment. In this triangle, we try to connect this, we'll call it A. If we try to connect it to a non-consecutive vertice, well, if we connected this one, that's already a side. If we connected that one, that's already a side. Triangles have, it's got three sides, but it's got no diagonals. And we already know that the three angles of a triangle, the three interior angles of a triangle, have to add up to 180 degrees. A four-sided figure, which is a quadrilateral, don't call something that it's not. We don't know anything else about this. Right now, all we know is it's got four sides. Quadrilateral. Hopefully I spelled that right. Quadrilateral. If we draw one diagonal in, now we actually have two triangles. And we know that this triangle is 180 degrees, this triangle is 180 degrees, so that all these interior angles, all these angles inside this polygon, have to add up to that 180 and this 180, which is a total of 360. So we got four sides, and we know that they got to add, all the interior angles have to add up to 360 degrees. And there's more diagonals there, and we're going to talk about it here in a minute. Next, if we got five sides, a pentagon, and we draw in the diagonals, and we just draw them in from one vertex, we have 1, 2, 3 triangles. Well, 3 times 180, that's going to tell us what all the angles of that pentagon have to add up to be. 3 times 180 is 540. So anytime you have a pentagon, all 5 angles of a pentagon have to add up to equal 540. And that's another thing I want to say, is that when we're talking about interior and exterior angles, if a shape's got 3 sides, then it's got 3 interior angles, and it's going to have 3 exterior angles. An exterior angle, remember, is just you take one of the sides and extend it straight out. That's an exterior angle. Maybe you take this side and extend it straight out. That's an exterior angle. So again, over here, if we look at the diagonals, if we go back to a quadrilateral, in a quadrilateral, that's not the only diagonal. We could actually connect this corner and that corner, and that would be another diagonal. So a quadrilateral actually has 2 diagonals. Triangle had no diagonals. Four-sided figure has 2. Five-sided, if we connect all, or if we draw in all the diagonals, it's going to look something like this. And if we counted all those, it would have 5. Now if we did a 6-sided figure, notice on the sum of the interior angles, of all the interior angles added up, it's going up by 180 each time. So we just take this 540, add 180 to it, and you get 720 degrees. All 6 interior angles have to add up to 720. And again, going back, if it's got 6 sides, then it's going to have 6 interior angles, and it's going to have 6 exterior angles. Those numbers are always going to be the same. Now to find the diagonals, if we look at how these diagonals, from here you went from 0 to 2, then you went 2 to 5, So we went up 2 here, or we added 2, we went up 3 here. If you see the pattern, we're probably next going to go up 4. So a 6-sided figure has 9 diagonals. 7-sided figure, I'm not sure why I underlined that. We'd add 180 to this, that gives us 900. So all 7 interior angles of a 7-sided figure add up to 900 degrees. And then as far as the diagonals go, we went up 4 the last time, so this time we'd go up 5, so it'd be 14. Then 8-sided, well, if we went up 5 here, that means we're going to go up 6 the next time, so that means that octagon would have 20 diagonals if we drew them all in there. If we add 180 to this, that'd be 1080. So all 8 interior angles of an octagon add up to 1080. And we're going to make a chart later on in the notes that deal with that. As far as the diagonals go, just know what a diagonal is, the main thing. Those are diagonals for this shape. We're not going to do a whole lot with being able to draw in all the diagonals or know how many diagonals a shape has. The first formula, n minus 2 times 180. This equals the sum of all the interior angles. The sum of all the interior angles of a convex. It's got to be convex. Concave doesn't work. This n right here stands for the number of sides. Number of sides. Main formula, n minus 2 times 180. So if we got some shape, we count the sides, 1, 2, 3, 4, 5. It's got 5, so we just plug in 5 minus 2 times 180. Do the subtraction first. So first you subtract. Then you multiply by, then you times by 180. So 5 minus 2 is 3, then 3 times 180 is 540. And hopefully after doing it a couple times, you know that every pentagon in the world, all the interior angles, every one of these angles, all 5 of them, have to add up to 540 degrees, no matter what that pentagon looks like. And then say for a hexagon, octagon, so on and so on. Next one. This is the sum of the exterior angles. Sum of all the exterior angles of a polygon. Notice it's not really a formula. It's just the sum always equals 360. So if I extend these sides out, and it's got to be the side going straight out, that's an exterior angle. If I could draw straight, that's an exterior angle. That's an exterior angle. That's an exterior angle. That is. That one is, if it was connected correctly. And that one is. So all those angles, 1, 2, 3, 4, 5, 6, 7, all 7 of those angles are going to add up to 360. No matter what the shape is, no matter what the polygon is, the exterior angles are always going to add up to be 360 degrees. So nothing to do there. If they ask you what's the sum of the exterior angles, then you know it's 360. Now over here it says 1 at each vertex. That's because when I extended this side out, at that vertex right there, I could have also extended that side out. But this angle and that angle are vertical angles, so they're the same. So we don't want both of them in there, because that just makes it more to do. So we want 1 at each corner. 1 at each corner. Next, an equilateral polygon, all the sides are congruent. The polygon's equilateral, that means lateral means sides, that means all the sides are congruent. So if I'm doing a 4-sided polygon, a quadrilateral, and I want a shape where all the sides are congruent, a lot of people are going to say a square, but a rhombus also works. And that's the one where we know all the sides are congruent, but we don't know all the angles are congruent. We go down equiangular polygon, all the angles are congruent. Well, if I wanted a 4-sided figure where all the angles are congruent, but all the sides are not congruent, that would be a rectangle. Rectangle. Because all the angles are the same, but all the sides are not the same. Now, a regular polygon is where all the sides, and we talked about this earlier this year, all the sides and all the angles are the same. Well, if I was doing a quadrilateral again, then that would have to be a square. Because we know all the sides are the same, and we know all the angles are right angles. When we were doing triangles, we said if a shape was equilateral, then it also had to be equiangular. That only works for triangles. It doesn't work for other polygons. Doesn't work for other polygons. Only works for triangles. Right. If a triangle, if a polygon is regular or equiangular, then we can find each interior angle or each exterior angle. And it's usually easier to find each exterior angle first because this is an easier formula. All right, that's an easier formula than this top one. The way we find it is we still find the sum, that's what's on top here, the sum of all the interior angles, and then all we're going to do is divide by how many sides that shape has. So if we take that 5-sided figure that we had earlier, that pentagon, we figured out that all the angles must add up to 540. All we're going to do is divide that by how many sides there are. You divide that and you get 108. So if you have a regular pentagon, then every angle in that regular pentagon is 108 degrees. Now instead of going through and doing all that, we could have just done this one, the 360, and just took 360 and divided by the number of sides, and that gives you 72. So we know every exterior angle of a regular pentagon is 72 degrees. Well then, if we have a regular pentagon, if I could draw a regular pentagon right here, probably can't, and we have an exterior angle, and we know it's 72 degrees, well this exterior angle and this interior angle have to add up to 180. They have to be supplementary. So if I found the exterior angle, all I'd have to do to find the interior angle is take this 72 and subtract it from 180. Well, if I do that, I end up with 108. So interior angle, exterior angle, got to be supplementary. Each interior angle, this is the formula. Each exterior angle, that's the formula. So you got 4 formulas. Formula to find the sum of the interior angles. Formula to find the sum of the exterior angles, which is just 360 every time. Formula to find each interior angle. Formula to find each exterior angle. On this chart, we're going to fill all this in, and I'm just going to go ahead and do it on this video for you. We're going to fill all this in. You should be able to fill in the names. The sum of the interior angles, we got to use that formula, n minus 2 times 180. Sum of the exterior angles, well, every one of these is going to be 360. 360 all the way down through here. Each interior angle, we could use the formula again, n minus 2 times 180, divide by the number of sides. Each exterior angle is 360 divided by the number of sides. Probably be easier to find all these exterior angles first if the shape's regular, and then just take each one of these and subtract it from 180. 180 minus each one, and that's going to give you each interior angle. So if I did a triangle right here, 360 divided by 3, that's 120. That means for a regular triangle, every exterior angle is 120 degrees. Well, then I just take that 180 minus 120, and I know every interior angle's got to be 60 degrees. And you could do that for all of them. This is the chart. You just fill it in with, on this one, septagon, could also be called a heptagon. And you'll notice with some of these, like a septagon and heptagon, those aren't real nice numbers. That's why we don't use 7-sided figures real often. We don't use 9-sided figures real often. 10, 12, and maybe. When we get down here to n, remember if a shape's got like 50 sides, we don't have a special name for it, so we just call it a 50-gon. It's got 22 sides, and we call it a 22-gon. Makes it easier. And then down here you also have all your formulas. On this paper, look at number 4. Number 4. My shape doesn't look exactly like theirs, but it'll be all right. They want us to find x. How are we going to find x? What's the first thing you got to do? And I said on most all these problems, you're going to have to do this first.
Add them all up and minus whatever.
Count the sides.
First thing you got to do is count all the sides and then use that to do what? Figure out what all of them should add up to be. You got to use this formula. You're going to use this formula on most every problem if you're dealing with the interior angles. All right? How many sides do we have here? 5, 6. Which one is it? 5. 1, 2, 3, 4, 5. So I put in what in place of n? 5 minus 2 times 180. Now some of you already know, because we've said this like 7 times today, if this is a 5-sided figure, what should all those angles add up to be? 540. Now once you have that, now we can add them all up. And this is what you're going to do. You're going to set up this equation every single time. 122 plus 100 plus, what do I put down for this? 90 plus, what do I put down for 144? I don't know why I said that. And then plus x. 1, 2, 3, 4, 5. All 5 of those angles should add up to be how much? 540. So you write equals 540. You've got to write this out. This is where most of you are going to, I see Chloe back here, and about 90% of the time she's dozing on her arm. This is where she's going to have trouble because she's not going to want to write it out every time. You write it out, then do you know exactly how to solve that? Yeah, because your algebra teacher did such a spectacular job last year teaching you how to solve algebra problems. So can we solve that once we're to this point? Yeah. Somebody help me out. We collect all these like terms. What do you get? 446? Yeah? 456. So we got 456 plus x equals 540. Now what? Subtract 456 on both sides. What do you come up with?
84.
So what's that angle right there? 84 degrees. Was that a regular pentagon? No, because all the angles weren't the same. You could probably do number 5, right? Same idea? Tell me the equation you'd set up on number 5. How many sides did it have? 6. Can you look on your little table and figure out what the sum of 6-sided is? Sum of the interior angles of a 6-sided. 720. So all that added up should equal 720. So on number 5, you add all those up, equals 720. Look at number 6. Let's do number 6. While I'm drawing it up here, somebody help me out and count how many sides we got.
4.
Got 4. So we know that they all total up to how much? 360. We know those two angles are congruent. We know that, and we know this is 120. Tell me the equation I can set up then. 120 plus 90, I heard, plus x plus what? How'd you know if this was x that this is x? They're the same, right? Now don't get this x confused with that x. That's the name of the corner, right? Two completely different x's. And we know all that should total up to how much? 360. 4 angles of a quadrilateral should always add up to 360. What's 120 and 90? 210 plus, what's x and x gives?
2x.
How do I solve that? Subtract 210. Good. What's What's that give us? 150 over there. What on the other side?
2x.
Now what?
Divide by
Divide by 2, what's x equal? So x equals 75. Not sure why that's written that way. X equals 75. Jump down to number 8. Number 8, what's different on number 8?
Exterior.
We're dealing with the exterior angles. So I don't have to draw this because I don't want to draw that. It's too hard for me to do. What do you know about the sum of the exterior angles? It's always 360. So just looking at that picture there in number 8, tell me the equation I could set up. 60 plus 64
Plus 2x.
plus 36, I didn't hear the next one. 48
Plus 2x.
plus an x and 2x or just one x? There's 2 x's. So x plus x, I'm just keeping them separate. And all that should total up to be how much? 360, because the exterior angles always add up 360. Now the reason I wanted to keep the x's separate, because you want to make sure you didn't miss anything. 1, 2, 3, 4, 5, 6. Was there 6 exterior angles on this shape? Collect like terms. What do we get when we put all these together? 208. Anybody else get that? Or are we just going to believe that Hannah is right this time? 208. Put these two together, what do we get? I'm hoping some of you are writing this stuff down there on your paper. If not, maybe I should have passed back the test first so you could see your score on that last test. Maybe you'd want to work a little harder right now. What do I do next? Subtract 208. 152. That equals 2x. Now what? Divide by 2. X equals 76. Oops. Is that what they wanted us to find, was x? Is that all it said, was find x? Yep. Look at number 10. Could you do number 9 on your own? What should add up? What? Tell me what to write down. Not number 9. So 90 plus 109 plus 73 plus x should equal 360. Solve that. Number 10, a pentagon has 3 angles that are congruent and 2 other angles that are supplementary to each other. Find the measure of each of the 3 congruent angles. So I draw some pentagon. I have no idea what this pentagon looks like. All I know is it's a pentagon, so it's got 5 sides. I know 3 of these angles are congruent. What they tell us about these other 2? What's that tell us? How am I going to solve that? How am I going to set up an equation from that? What could I make this angle right here? How about this one? This one?
X.
So 3x plus 180. Do we really care how much that angle right there is? No. Do we care how much that angle is? No, but we know that those 2 together add up to 180. 5 angles, 5 interior angles in a pentagon should add up to be how much total? We've done it like 75 times now. 540. How am I going to solve that? Minus 180. Somebody do that for me. Then what do you do? Divide by 3. What do you come up with? So what's this angle right here? So that's our answer, 120 degrees. Number 11. Number 11 is quite a bit harder. Watch closely on this one. You're designing an amusement park ride with cars that will spin in a circle around the center axes. and the cars are located at the vertices of a regular polygon. How many sides do we have? In a regular polygon, how many sides? 4? 3?
You have any?
We don't know, do we? It's just some polygon. They didn't tell us number of sides. So guess what we're going to have to find this time? We got to find the number of sides. All right? So we're actually working the problem backwards. These are the harder ones. So make sure you're watching closely on this one and writing this stuff down for number 11. The sum of the measures of the angles, so that all the interior angles of this regular polygon is 6,120. You could look on your chart. The bad thing is, if you look on your chart, it's not on there. It's too big. We didn't put that on the chart. All right? So what we need to do is we know that the sum of all these is 6,120. What's our formula for all the interior angles of a polygon? N minus 2 times 180. Well, we know that this should equal how much? 6120. Now, even though we're working backwards, is that an equation we can still solve? Yeah. Now, when we were doing this equation out normal, first step, we subtracted 2. Second step, we times by 180. What are you going to do if you have to work it backwards? And you might want to write this down. Not times by 180. So first step now is divide by 180. And then the second step, add 2. So we're going to take this, and we're going to take this number, and we're going to divide by 180. Then we're going to add 2, just working backwards. So we divide this by 180. Divide that by 180. You divide this side by 180. These 180s cancel out and leave you with just n minus 2. And what'd you say it come out to be? 34?
Yeah.
Now what do we do? Add 2. What do you come up with? What's that tell us? What's n stand for?
36 sides.
So how many shapes does this polygon that they're messing with have?
36.
Or how many sides? I mean,
36.
36. It's got 36 sides. So this polygon's got 36 sides. What's the name of that polygon then?
36 gone.
36 gone. Flip over to the other side.
Take a lot, Mike.
Flip to the other side. On the other side, jump down to number 7. Number 7 says find the measure of each interior angle and each exterior angle of a 24-gon. Of a regular 24-gon. Well, if it's regular, what do we know about all the interior angles? They're all the same. How about all the exterior angles? They're the same. And they add up to 360. What I'm going to do first, we could find, everybody always wants to find each interior angle first. I wouldn't do that. If I'm looking for each interior angle, each exterior angle, I'm going to find each exterior angle first. Cool. So what's the formula to find each exterior angle of a regular 24-gon? 360 divided by number of sides. So here I'm going to put 360 divided by what? 24. Somebody help me out. What is 360 divided by 24? 15. So what's every exterior angle on a 24-gon? 15 degrees. How am I going to find this interior angle?
180 minus 15.
You just take 180 minus that, and that would tell you that. What's that give you? 165. So for a 24-gon, every interior angle is 165 degrees, every exterior angle is 15. Now, if you did start up here and find each one, then you just use this formula, and you do 24 minus 2 times 180 divided by 24. What's 24 minus 2? 22 times 180. You grab your calculator and you do it, right? Once you get that answer, what are you going to do to it? Divide by 24. It's going to give you the same answer. It's going to give you this 165 right there. All right? But was it easier to do it, find the exterior angle first, then the interior angle, just by subtracting from 180? Probably so. Page 364. Now, it looks like a lot because it's 1 through 30. I sat in here yesterday after school and was helping a couple of students with this. And I think we got up through like problem 22 in like 30 minutes. Because all of them are just what we were doing. Now, we got up to problem like 22. But that was within screwing around an awful lot. Alright? If they would actually just worked in that 30 minutes, we probably could have got the whole thing done.